Alright, so we start our chapter 6, area of triangle. I hope you guys are good with triangles. Alright, so you can see this guy on the picture. He is working with the window, and the window has these triangle pieces of glass. And he's asking the question. These are the questions we're gonna talk about. So these are two lessons. Area of triangle, composite figures, right? So in the refresher course, maybe you remember what is a composite figure. We're gonna talk about this. All right, let's get started. So lesson 1, area of triangle, right? Identifying the height of a triangle given its base. Before you learn, a rectangle has length 8 centimeters and breadth 4 centimeters. Lily cuts the rectangle into two equal triangles. Identify the base and height of each triangle. Okay, all right, so you have your rectangle, and this is gonna be 8 centimeters, right? And this is gonna be 4 centimeters. 4 centimeters, right? And Lily cuts it like this into two halves, right? Into two halves. So they ask us identify the base and height of each triangle. So this is what we learned here. A triangle has 3 vertices and 3 sides, right? So vertex, this is called the vertex, right? Or vertex is the plural word, and singular is a vertex, right? Vertex of a triangle, right? This is dot that is created by intersection of on the intersection or cross, intersection of two lines, right? Okay. And as we discussed before in the refreshing video, right, they create an angle, right? And usually what we do, we give them the name. The name is a letter, so A, B, and C. And then we can call our sides AB, BC, AC, right? So this is easy. It just makes it easy to identify everything. Okay, so learn 1B. Any side of triangle can be its base. Okay, we can take triangle, we can rotate it in the plane and consider any side as a base. Well, whereas the height of a triangle is perpendicular to its base, right? So let's check. Let's take a look on this triangle, right? So it's just a random triangle, ABC, right? And they choose one side as a base. They choose BC or CB. BC is better, I guess, as a base. And the height of triangle is this line, should I say, right? That goes at a right angle. That creates a right angle with the base, right? So this is what they tell us. CB is the base, and AD is the perpendicular line from A to CB, so AD is height, right? Same thing here, right? It's just they show us identical, so it's the same triangle everywhere. They just show us that we can choose any side. So in this case, the AB is the base. We can choose any side as a base, right? And we can put a line to it, perpendicular line. So create this right angle, and it will be height. So same story here and here. Okay, take your time, read it through, process it. Everything is easy, and we'll move on. Now, situation is a little bit different if we take a triangle that has an obtuse angle, right? Like in this situation over here, right? So again, same thing. They show us the same triangle 3 times, right? And they show us that we can choose anything as a base. So in this case, RQ is a base, right? But in order to identify the height of it, right, this thing, we need to kind of, this is called extrapolate. Yeah, extrapolate means make the line longer, right? And then we put our perpendicular line, and this is how we identify our height, right? This is what happens again in the second case when we take this one as a base, right? When we want to put from here, from the other vertex, a perpendicular line, we cannot do it, so we kind of extrapolate it like this, and then this is the height, right? And lastly, in this case, everything is standard. If we take this side, RP is a base, QU, right? So they put this U point, right? This will be the height. Okay, gonna clear it up. Take a look at this. All right. Next step, we can use a set square to draw the height of a triangle for a given base, right? So yeah, if you have like a special ruler, right, like this, and you work with your triangles, like this blue thing, right? And you work with triangles, this triangle ruler, how do you call it? Yeah, it has a right angle, and you can draw your lines, perpendicular lines, anywhere you want. Yeah, I guess. Yeah, they call it set square. Sorry, I guess. And yeah, and you can put it on any vertex and make a perpendicular line. So this angle will be right angle to the base, and that's it. You just give a label. So they mark it as a point D, for example, right? Okay. So basically, on the step 2, they show you that, yeah, when you remove the ruler, right, this you already drawn this line, so this is the height, right? So with with obtuse triangles, right, with the triangles that have an obtuse angle, right, the story is the same. You place your set square like so, and this will be your right angle, right? And this is kind of your extrapolation of the side of the triangle. So when you remove it, right, this line, perpendicular line that you draw, will be the height. Okay, pretty straightforward. So this thing is to basically give you the main idea of what is a base. Anything can be a base, any side can be a base, and the height is formed by making a straight line, perpendicular line, right, to the base. Okay, let's move on. So that's the first hands-on activity, right? Work in pairs, draw triangle ABC on square grid paper, list the possible bases, right? And blah 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 blah. Very easy, right? So yeah, I assume you have a piece of square grid paper, so-called, right? So this is the paper with square grids. Okay, and draw a random triangle and try to identify what is base, what is height. Here is the example, right? And they ask you to draw the same thing. Well, everything is straightforward. I'm pretty sure you can do it yourself. Let's check on the first exercise, right? Name the base or the height of each triangle, right? Okay. For the height AD, so this is what we identify, right? This is the height AD. This is the height AD. The base is, what is the base, right? So the height AD is this perpendicular line forming the right angle to which side? This side, right? So we can call it BC or we can call it CB. So this is what we do, BC or CB. All right? Okay. The next one, for the base and M, the height is, right? This is our base, right? And they ask us what is the height? You extrapolate, here is your right angle, and here is the perpendicular line, and your base is LQ or QL. LQ or QL. Very simple. All right. Gonna erase this thing. Think about it again. Okay, next page. Finding the area of triangle. Alright, before you learn, Tammy draws a triangle. Its base is 10 centimeters long and the height is 8 centimeters long. How can she find the area of triangle? Alright, and this is a random question, and this is how they explain us, right? Read it through. So from this picture you can see, right? So basically the area of a triangle is the area of the half of the rectangle. So what you need to do is just calculate the half, right? If you studied the previous 3 chapters well, you know the fractions. So the fraction, this is how we represent half, 1/2, right? So 1/2, and the area of a triangle ABC, this blue triangle, right, is a half of area of rectangle ABCD, this rectangle, right? Okay, so this is what we do, right? We find the area of a rectangle, right? So we can see this one side of this little square is 1 centimeter, right? So 1, 2, 3, 4. This is 4, right? And then 1, 2, 3, 4, 5, 6, 7, 8. This is 8, right? 4 times 8 is the area of the rectangle, but we add a fraction, we divide it by 2, and this is how we find the area, 16 square centimeters. Okay, all right, very easy. Okay, so on the next page they give us several examples so we could learn how to recognize the relationship between the area of a triangle and its related rectangle, right? So yeah, basically you'll understand everything from practice. Check the figure A, right? There is a triangle, right triangle, there is a base, there is a height, yeah, and there is a related rectangle. By related rectangle, they call the rectangle that contains this triangle, right? So we can see that it is half of it, right? And yeah, you can draw it again. So I don't want you to be confused by this word breadth. It means how broad it is, right? How broad. Another word for that is how wide it is, or the noun is width, right? Width. So this is this side, right? This side. So you can see if you have a grid, square grid paper, and you draw it this way, you will see that this triangle here is identical to this triangle here, and this is why they show us by the area that this area and this area here is the same area as over here. Okay, all right, let's finish with this. So number 2, right? Find the area over here. The exercise number 2. Find the area of the related rectangle and the triangle in square units. So our first related rectangle, length is 4, breadth is 3, area is 12. How did they find this? Here, length is 4, breadth is 3, 4 times 3 is 12. This is the area of the rectangle, right? Now let's take a look on our triangle, related triangle. Same thing, base is 4, right? The height is 3, 1, 2, 3, right? But we already know that it's half of it, right? So base is same, 4, and then 3, but the area is twice as little, right? So 6, area is 6. Okay, let's take a look. I'm gonna erase this so it doesn't confuse you. Let's take a look on the figure B, right? Figure B. Here is the triangle, and again, related rectangle is the one that contains this triangle. You can illustrate it like so, right? And you can see basically this piece, right? This small piece is the same as this piece, and this small piece is the same as this piece. They're showing you that again, the area of triangle is half of the rectangle, of the related rectangle. Yeah. You calculate your lengths, you calculate your breadth. So here 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. Right, length is 6, breadth is 4, 6 times 4, 24. For the triangle, same base, same height, 6 and 4, but the area is twice as less. 24 divided by 2, 12. Right? I hope you follow. Lastly, last one. I want to really go fast through it. So here, right, there is a base, right, and there is a height of your triangle, right? So if you extrapolate it like this is the height, right? Perpendicular. This is what they show you. Okay, so you have your base, you have your height, and from the base you can see, right, this is 2, and from the height you can see that this is 4. Okay, now let's think of the related rectangle over here, right? They tell you that this piece, this rectangle, we can find identical pieces, right? So if you do it on the grid paper, you can see like this piece gonna be completely identical to this piece, and of course this piece over here will be identical to this piece over here, right? 2 by 2, right? So your length is okay. So they're showing you with the red, right? This is the related rectangle. Don't be confused. Why is it taking this area? Because this triangle is here, right? So they kind of showing you that this rectangle captures this area, right? So related rectangle has a length of 2 and breadth of 4, 2 and 4, right? And its area is 8. So same thing, 2 and 4, 2 and 4, but the area is twice as less. 8 by 2, sorry, is 4. All right. Okay, take your time, process this thing. All right, question 3. From the table, what do you notice about the base and height of each triangle and the length and breadth of its related rectangle? The answer is the base and height. You can see 462, 462, 344, 344, right? So the answer is the base and height of each triangle is equal to the length or breadth or length of its related rectangle, right? Very easy. So length and breadth of related rectangle is the same as base and height of a triangle. Okay, next question. What do you notice about the areas of the triangles and the areas of the related triangles? What do you notice? This is what we discussed already. Our observation is that areas of the triangles are half of the areas of the related rectangles. 12, 6, 24, 12, 8, 4. Half of it, right? Always. And lastly, what is the relationship between the base of the triangle and the height of the triangle and the area of the triangle, right? All right. So this is something that we did on the previous page. Sorry, you cannot see the question. I'm gonna do like this. All right, now you can see the question. Right. Relationship is, but I have to draw again. The relationship is that always area of triangle, yeah, is what? As we said, half, and then you multiply it by base, multiply it by height. All right, that is it. Okay, so we move on, and now we have to try everything ourselves. Exercise number 1, find the area of triangle PQR. All right, well, I assume you've done everything yourself, right? I'm just gonna explain it really fast. So area of the triangle, we know now, right? It's half of the base and the height. So when we multiply base and the height, we will get rectangle, and half is the area, half of area of this rectangle, right? That's it. So our base over here is 38, right? Our height over here is 15. This is what we write: 13 times 15. Oh, sorry. And if you do your math well, you're gonna have 285 square centimeters, right? Next one, find the area of each shaded triangle. Each shaded triangle. Here you have a rectangle, the side of 16 and the side of 17 centimeters, right? What do? You multiply them and you divide it by 2. 1 over 2 times 16 times 17. All right. You should get the answer of 136 square centimeters, right? All right, same thing here. Multiply two sides, divided by 2. The answer is 182 squared centimeters. Okay, C. All right. All right, that's a bit tricky. Don't be confused, right? So, if you want to find the area of this triangle, you need to find the areas of this triangle first and the whole rectangle, right? So first of all, the rectangle, right? You need to find this side, so you add up these two. It's going to be 20 plus 18, 38. 38, and this is 25 side. 38 times 25. You're gonna find the whole area, right? Okay, and then you need to find this rectangle. Oh, sorry, not rectangle, but you can do directly, right? You can find this triangle, which will be the half of the product of these two numbers, and this triangle will be the half of product of these two numbers, 18 and 25, right? And then you basically just subtract. You subtract the whole area that you found first minus these two triangles. All right, I don't want to do the math. Math is yours. And I'll just give you the answer: 475 square centimeters. All right. Okay. Next one, right here. What do? They just show us that the base is split into half, right? So 14 plus 28, that's gonna be the one side, which will be what, 42 meters. And you have your height, right? If you want to find the area of triangle, half times 42 times 23, right? And your answer should be 483 meter squared. Sorry, I got a little confused here, right? I thought it's a squared triangle, right? I'm gonna explain this again, sorry. So that's gonna be they show you two different triangles, right? Triangle 1, triangle 2. So triangle 1 and then triangle 2, right? So you find the area of this triangle, so this height and base divided by half, right? And so what is it, 1.5 times 14 times 23. This will be the area of this one, and then you need to find the area of another one. 28 times 23 divided by half, right? Half times 23 times 28. Okay, so you find these two numbers, and they will be the areas of these triangles, and then you sum up, right? And then you will get your answer, 483 meters squared. All right, the next one, the yellow. Right, we have our base, we have our height, right, that is perpendicular to the base, right? So you multiply these two numbers and you divide it by 2, and so 1.5 times 31 times 56, right, which is 868 centimeters. I don't know why did they give this. Probably they just want to confuse you. All right, next, then the last triangle. Yeah, you have, what is it? There, this is the base, and we extrapolate the base, and here is the height, and here is the right angle, right? Okay, yeah, so definitely they just give you these random numbers just to confuse you, right? You don't need this thing. You need to identify what is the base, and you need to identify what is the height, right? So 12 times 15 is going to be the area of rectangle, related rectangle, right? And if you calculate it like this, it's going to be 90 square meters. Yeah, definitely. This is all these things, these numbers. They just given for confusion, right? So yeah, don't let them confuse you. Pay attention. Okay, that's the last page of lesson 1. 1C, right? So they give you a triangle, yeah, and everything is on the picture. You can read it, pause the video, read it through. Basically, all of these problems, they just want to make sure that you are able to identify in each type of triangle what is the base, what is the height, right? So 1C, QR, this is the base. We extrapolate it. Here is the height, perpendicular. Yeah, so 26 and 26. So we multiply them, divide them by 2, and we got our answer, 338 centimeters squared. Okay, next thing, look at this triangle, right? Everything here is the height, here is the perpendicular line and right angle, right? And this is the base. So this is 18 and the base is 9 plus 10, right? So 1/2 times 18 times 10 plus 9 is 19. The answer is 171 meters squared. All right. Okay. Lastly, in the last thing, here is our base. We extrapolated here, and then we here's the perpendicular line, angle. This is our height. This is our this is our base. This is our base, right? And we calculate it. So 1/2 times 14 times 18. The answer is 126 centimeters squared. Okay. All right. Here, workbook practice 1. Make sure to solve it through. And I also will make the video for it later. All right, math sharing. Here for each triangle, find its height, then find its area. Okay. All right. So let's go. Here is base. Base is 3, right? Here is height. This is the perpendicular line to the base. Here is the rectangle. The height is 4, right? So 3 times 4, 12. 12 by 2 is 6. Whatever. What is it? Unit. So square units. But let's make our unit a centimeter. Right. Okay. Next one. Here is the base. Right. We need to make a perpendicular line. Here is the perpendicular line. This is our height. Height is 4. Base is 3. 4 times 3, 12. Divide by 2. Again, 6 squared centimeters. Right. Okay. Here triangle number 3. Here is our base, perpendicular line. Here is our height. Right. Our height is 4, and our base is 3. Same thing. 3 by 4, 12. Divide by 2, 6 centimeters squared. Right. Last one. This is our base. we extrapolate it, right? We put the perpendicular line to it. This is our height. Our height is 4, our base is 3, again 12, and divide by 2, 6 centimeters squared. Discuss with your partner what you noticed about the areas of different triangles with equal bases and equal heights. Yeah, find your partner and discuss it. Alright, that was the finish of lesson 1. I'll see you in the next lesson.